This is Brimley Newton with BNL Consulting, and in this video I'll be showing you how to use the BNL SAS Code Analyzer to run code inline and analyze the log. The first thing we want to do is deploy the SAS code to the SAS application server. I have my zip file here on my desktop, and I've also got a projects folder called SAS Code Analysis that exists on both the client machine and the application server. This is where I'm going to be putting the SAS code. So I'll go ahead and paste my zip file here and unzip it. And then we can delete the zip file as it's no longer needed. And so here we can see I have 4 new folders. Analysis results. This is where all of our HTML data is stored. This includes the graphs that are created by the application. Data. This is where the actual data on the logs exists. Logs. This is a folder where any temporary logs are stored. And SAS code stores all the SAS code and macros, as well as the SAS configuration files if they exist. Here you can see I already have some existing configuration files as well as an existing log. In this video, we'll be running code inline. So we'll go ahead and open up the inlinerun.com and examine it. At the top here, you can see a description of all the variables. And at the bottom are the actual variables themselves. Base drive is where the code exists. So we're saying it's in BNL transfer users Brimley Newton project SAS code analysis. So I'm already logged into the application server here. I wanted to show you that that location actually exists. So you can see we have the same folders here. So we have the existing log file, the configuration files, and the 4 folders from before. Log file to parse. This is going to be blank because we're running this inline with an existing program. Log file folder is currently based on the base drive. This could be changed to a custom location if wanted. The new performance log. This is the temporary log that's created when the program is run inline. Append. When the program is run, it creates a data set related to all of the data steps and proc steps in the log. This says whether to append to that data set with new data or to create a new one. The output data directory. This is where the data on the data step and proc steps is stored. The output data member. This is the name of the data set that's created. The out data graphics directory. This is where the HTML results and graphics analyzed on the application are created. Measurements. This is used by one of the macro variables. We won't be using it in this demo. The run analysis request. We'll leave this set to 1. This is used if you're going to be analyzing the same program more than once. SAS program. This is the code that we're going to actually run. An execute program tells us whether or not we want to actually run this code. And as we're running it inline, we do want to run this. So we can go back here to our code. We open SAS code, then SAS code analysis. We're going to go ahead and open that up in Enterprise Guide. We need to modify this configuration file to point to the one we're actually using. So go ahead and back this off, paste this, and now we're good to go. And now we can go ahead and run the program, and what it's going to do is run through it in its entirety, and then it should spit out some graphics here at the end. So we'll go ahead and run this, and this is going to take a few minutes to run. Now that the code's finished running, we can see our results over here in the results tab. At the top we have summary, real-time, sys-time, operating system memory, the bulk input, bulk output, and the number of page faults. The first set of graphs we have are based on the top 1% of the data step and proc steps. So here you can see that SQL looks like it took the proc SQL steps. We're taking the majority of the time here. Same here with system time. As far as memory, the proc sort steps look like they were the main competitors there. For the bulk input, you can see we have the sort steps followed by the SQL. Output are the data steps and stored steps. And then for the number of page faults, you can see that proc append is the winner there. The second set of graphs contain the entire program. This essentially is every data step and every proc step. So this data is interesting, but doesn't give you as detailed information as the first set of graphs. So you can see there that it has a lot of system time usage at the beginning. It slows down for a lot of the intermediate steps, and then it increases again at the end. And there are similar graphs for each of the other operating system variables. One thing that's important to note, if we go back here to our configuration file, this program that we ran does not use a proc print2 step to redirect the log. If it had, we would have had to place the log file to parse. We'd have to include this in there. So say it went to /temp/log file. We would just need to include that. So what it would do is it would include that log file as it's redirected from the program when it's doing its analysis. And that's it for the execution of the code analysis inline.